Today we're going over 5.5 quadratic equations. So the only difference between quadratic equations and quadratic expressions from the 5.4 lesson is that now we're going to have an equal sign and we'll be solving for the variable, in most cases x. So for example, let's say we have the quadratic x squared minus 4x minus 21 is equal to 0. So we're going to factor this by saying what multiplies to negative 21 and adds up to negative 4. So if you can't think of what that is, you can list all of the factors that multiply to 21. 1 times 21, we'll have 3 times 7. And we know that one of them will have to be negative because it multiplies to a negative and it adds up to a negative. So since it's adding up to a negative, the higher absolute value has to be negative. So we look at both of these and the one that will work is 3 plus a negative 7 will give us negative 4. So when the value of a is 1, we go straight to the two binomials and we'll write it as x plus 3, x minus 7. And you can always check that you got this correct by using the FOIL method. From here, we're going to make a t-chart and set each binomial equal to 0. And then we'll solve this linear equation, each linear equation. So we get x equals negative 3 by subtracting 3 from both sides, and x equals 7. So this is giving us the value of x. It's also, if we needed to graph this, if we wanted to graph y equals x squared minus 4x minus 21, these would be the x-intercepts of our graph. Okay, moving on. We want to look at when the value of a is not 1. So for example, let's say we have 2x squared minus 11x plus 15 is equal to 0. So when a is not 1, we're going to do a times c, 2 times 15, the factors of 30 that adds up to negative 11. So since it has to multiply to a positive and add up to a negative, that means that we're going to have two negative numbers. So we'll have either negative 1 and negative 30, negative 2 and negative 15, negative 3 and negative 10, negative 5 and negative 6. So the pair that's going to add up to negative 11 will be the ones that we use. So right here, negative 5x minus 6x will give us negative 11x. So we're going to replace negative 11x with negative 5x minus 6x. So we get 2x squared minus 5x minus 6x plus 15 equals 0. And then we're going to factor out what we can from the first two terms and from the last two terms. So from the first two terms, we can take out an x, and we're left with a 2x minus 5. And then we have to have the same binomial left over, so we can rewrite it, 2x minus 5. And we say, what do we take out from these last two terms to have 2x minus 5 left over? So we can take out a negative 3 here and then check it. Negative 6x divided by negative 3 will give us a 2x. 15 divided by negative 3 will give us a negative 5. Then we'll say, what did we make both of these have in common? That's a 2x minus 5 and an x minus 3. From here, we're going to make our t-chart and solve for x. 2x minus 5 equals 0. X minus 3 equals 0. 2x equals 5. So x is 5 over 2, or 2.5. And x equals 3. So we have two x-intercepts. The next thing we have to go over is when there is no bx term. So when there is no bx term, meaning a linear term, it will be in the form of ax squared is equal to c. So for example, we can say we have 5x squared equals 180. So we're going to solve for x by first dividing both sides by 5. That will cancel. We're left with an x squared. 5 goes into 18 3 times with 3 left over. 5 goes into 30 6 times. We're now going to take the square root of both sides in order to get rid of this squared. And whenever you take the square root of a number, you're going to have two answers, which will be plus and minus 6. So we have two x-intercepts, x equals negative 6, and x equals positive 6. And that is solving quadratic equations.